So, good morning, all. Welcome to this session. What is our agenda for today? Agenda for today is finding the length of the linked list, inserting in a linked list. When I say insertion, insertion is taken into three different cases. One is insert at first, second is insert at last, and the third is insert at a particular index, right? For anything that we are doing, any code that we are writing, the first thing is, let's say your manager or the interviewer says, hey, write this, right? So you should be taking into consideration every case, right? Every case. When I say every case, you need to yourself analyze that what would be the cases that will be coming into this part. So in our case, whenever I say uh, I need to insert into linked list, the things that should be coming into my mind is, what if linked list doesn't exist? What should I do? What if linked list is out of memory? In that case, what should I do? These are called as extreme cases, guys. These are called as base cases. Base cases exist not only in the program, but not only in the program. Base cases exist not only in the program, but even in our thinking as well. Whenever someone asks you to code something, you should think in an extreme manner. What happens in this case? What happens in this case? This is a simple program, but as we move forward in the course, so there are places where you need to think extreme, and from that place you need to move yourself further so that you can code that in a better way, right? You can code that in a better way. At this point, I'd like to say one more thing, guys. The only reason why you learn data structures or algorithms or competitive programming, or the way you improve your code, etc., is to cater for the need of improving the system, right? When the input is finite, when the input is, let's say, 100, 200, or whatever it is, then there's no point of learning data structures and algorithms. The only point of learning data structures and algorithms is, if the input is increasing, how well your code is going to cater that input, right? So this is the reason, guys, why we have to think out of box, right? Before we try to write the code itself, we should think, what if this case happens? What if this case happens? What if this case happens? So this is an important thing for you to learn. And one more important point that I want you to tell at this point is, maybe I'll be telling that even further in our problem solving, but here the important point that I'm telling you is, every time when you try to say something or do something, think loudly, right? You may think this term itself is not seeming good. What is thinking loudly? Thinking loudly is nothing but, whenever somebody asks you to write something, i'd say uh, I say, hey Daniel, write something for write this code for me. So I'll be giving you a pen and paper with you. So you should be having a pen and paper. So let's say it's an interview, right? So you can start writing. So it's not just start writing, guys. It's thinking loudly and start writing. What is thinking loudly and start writing? So it should be like, whatever goes in your mind, that should come in your in your mouth, but that should be in a way that it's visible, it's audible only for the interviewer. Like, okay, sir has given me a linked list, so what should I do? I'll be doing in this way, I'll be doing in this way. No, this case occurs, so I should be coming here, I should be coming here. So everything that goes on in your mind should be coming on your mouth, but that should be coming in very low tone, so that only person who is judging you is able to understand you're thinking something in your mind. This has positive thing in it, guys. The positive thing in it is, let's say you're thinking in a wrong way, or let's say you're thinking in a negative direction, the person can correct you then and there, so that a lot of your time is not wasted, and you'd be using your time in a best or better possible way, right? This is just a trick to impress people, guys. So we have to use that. This comes only with the practice, right? So from now onwards, one more thing is, you should be like, by now we learned something. We need to have some coding standards, golden rules, etc., right? Whenever you try to write something on pen and paper, or even on computer, speak, think loudly, put whatever you're thinking onto your mouth, so that it'll be very low in tone, and the person who's judging you is able to see what you're thinking in your mind. This will save a lot of time. Believe me, you will see its miracles only when you go for the interviews and try to use this so that it benefited me, it benefited most of the people, right? I'm telling you with this experience. At this point, guys, let me introduce our agenda again for you. So what is our agenda? Agenda is finding the length of the linked list, and then how do you insert the linked list? Insertion comes into three cases: insert first, insert last, and insert at a particular index. So we'll be seeing all these three codes now. So what is the coding standard that we are trying to learn today? The coding standard we are learning today is modularization. Modularization is nothing but any code that you have to write, you should break that into different methods, different modules, right? Let's say you can write everything in a particular class in a particular method, but you should think of categorizing them into different methods so that your code looks clean, right? Your code looks clean and that impresses the interviewer. So I'll be coding right now and we'll see how do we modularize the code and how do we improve our code to impress people, right? So we can straight away jump into Eclipse, right? We can straight away jump into Eclipse. What is our agenda today? Let's try to see our first agenda, right? So here, what I'm doing, instead of showing you the code that's already there, I'm trying to write a class so that it becomes easier for you. Now, I'm trying to say Control N. What I told you, we should be having a node class, right? Just a second, guys. This Eclipse has been struck. Okay, that's fine. Yeah. So what am I doing? Let me create a class. The class, its name is node, right? Its name is node. And what is this node? This node is nothing but a linked list node. So what are the linked list nodes containing? The linked list node is containing, first thing is a pointer. First thing is the data and the pointer to the next element, right? And the pointer to the next element. Parallelly, I'm opening the whiteboard also so that that becomes even more clear for you. I'm opening up the whiteboard. Okay. Yes. Just a second, guys. I'm opening it up. So what am I trying to write here? I'm trying to write a class called node. This we have already taken, but let me try to write it once more so that you get even more familiar. So what is this node class containing? Node class is containing two parts. First part would become of type node, right? Here's what it is. Okay. So every node contains two parts, as we learned, two parts. First thing is data. Let's say I'm having the data called 1, and the second thing is pointer, right? This points to the next node, right? This points to the next node. And if this is the only length of the linked list, then what happens? This becomes head, right? This becomes head. This is the only linked list, then becomes null, right? So here, let me try to write the same class here. What am I doing? I'm saying int data, right? Again, node next, right? So I'm doing this, and let me try to create a constructor. So you know what is a constructor? Constructor is used to initialize the object. This we have already learned. What am I doing? Source generate constructor using fields. Not sure why this is stuck today. Okay, so generate constructor using fields. I'm not having next over here. And what am I doing? Just a second. Yeah, I'm clicking on generate, right? So once I generate, I have a constructor is a public constructor, and that constructor is having only one property, which is data, right? So by taking this, we'll be creating one more class. Let's say I want to calculate the length of the linked list. So here I'm saying, linked list length. I've created a class something like this. So when I create a class something like this, so what should I do? I have a class like this. Let me create a method public. What will I be returning when a linked list is asking for length? It should be an integer, right? Get linked list. So I'm writing something like this, get linked list length, right? So what am I passing for this? I should be passing the head pointer, right? Node head. When you pass something like this, so this method, or I'll remove this LLO. So I'm writing a method called get length, and this get length is returning me an integer, right? It is returning me an integer. So first and foremost thing that we need to do is we need to get the base cases written first. So people write base cases in the middle, people write base cases at the end, or whatever place they are convenient with. But I'm trying to write the base case at the top so that it becomes easier. I mean, we are following that that coding standard again, right? Base case. So what is the base case? If I told you we need to ask I told you we need to ask questions to interviewers, right? You're trying to find the length of the linked list. What if the length of the linked list is null? What if head is pointing to null? So obviously, when you ask this, he'll be giving you an answer. Like in that case, the length of the linked list is 0, right? So what you do, you try to say that return 0, right? So why should we ask the interviewer this question, even though we already know it? It's like it's an interaction, building up an interaction. Asking the correct questions to the interviewers in the interview is the key role, is the key in passing the interviews, guys. Remember that. Okay. So I've written the base case for this. Now what I do, I told you we should never modify anything on head, right? We should never modify anything on head. So what am I saying? I'm creating a new reference variable called P, and that P is pointing to head, right? Node P is equal to head, right? So here, what am I doing? I should be counting the length of the linked list, number of nodes, right? I'm trying to do one thing. I'm taking count is equal to 0, right? I've taken a variable called count, and I'm initializing that with 0. Now let me try to iterate over loop one by one. So let's say this is our input at present. So what is our input? Let's say we have something like this, right? So this is pointing to 2, this is pointing to 3, and this is null. Okay, and this is head, right? So what is the length of the linked list? 1, 2, 3. So how did we get till there? We came here, we tried to iterate, and from here we came here, from here we came here, and finally we have some variable called count, and we are summing that up and finally saying 3 is our length of the linked list. So the same code, let me try to write here. What am I doing? I have taken a count called 0. Here I'm checking while. So what am I writing in my while here? While P is not equal to null, right? P is not equal to null. So what am I doing when P is not equal to null? I'm saying count plus plus. count plus plus. This increment decrement operators, this I think this should already be covered in your main course of Java. The instructor will be taking care of it. But here what am I trying to do as part of line number 12 is I'm incrementing the count by 1, right? Because you came into the loop for the first time, you're incrementing the count by 1. So here what am I doing? P is equal to P dot next. So you're saying P is equal to P dot next. And what will you return? You will be returning the value of the count, right? You'll be returning the value of the count, right? Return, right? You'll be returning the value of the count. That's it. So with this simple code, guys, with this simple code, what we have done is we have taken a base case, and after that we try to create a new node, and from that we try to count it, and we had a while loop, and we incremented the count. Finally, we returned the count. So I'll try to write on this. I'll try to do it simple, or instead of running it, I'll straight away run that in our Eclipse in the debug mode, right? So that it becomes even more easy. So linked list length. So one more thing, guys, one more suggestion for you is, as you start coding, right? As you start coding, make sure everything is there in a particular workspace in your Eclipse, because this becomes a bigger reference. It may take time, or maybe you may take time to actually go to the interviews, etc., etc. But when you do your homework, when you do everything, try to maintain everything at a particular point, so that that becomes very easy for you to actually, revise that, right? Even if it passes 2-3 years. Let's say you want to revise the same topic again, you have that in the workspace, and like you can learn from it, right? Just a suggestion. So here what am I doing? I have okay, let me open this up. Linked list length, right? So I've already written the same program, right? Previously I told you that I will write a main method. In our previous class I told you how to write the main method and all. Here what am I doing? There is a node called 28, 27, 26, 25, and then this is how we have constructed the node. Let me try to call this, so that we will see what is the output. Okay, so what is the output? So what is the output right now? Does not contain main type. Why? Run as Java application. Editor does not contain main type. I think there's a problem with the Eclipse case, but this is how it is. I mean, this is the program, and after that, when you try to run, so you'll be getting the length. The same program we'll be considering even in the linked list insert. Okay, we'll be considering even in the linked list insert. So I'll be explaining that to you at that particular point. No problem. There's a problem with the main method over that, I think, because maybe Eclipse has crashed or whatever it is. So here at this particular point, what I want to say is, we have completed our code for one particular thing right now. So what is that? That is finding the length of the linked list. So by using this finding the length of the linked list program, we are able to find the length, right? So now let's move to the next part of our agenda. What is the next part of our agenda? Next part of our agenda is to insert in a linked list. Insertion has three different points, as I told you. So insertion has 3 different points. So I'll be explaining those 3 different points to you right now. So let me open up the whiteboard. Before you try to write the code itself, when you try to write some code related to the insertion logic, let's say the insertion can happen in various cases. You should be thinking about various cases before you start the code itself. So what is that? Base cases, right? Base cases. So how should the base cases you be saying? What if null? Null in the sense, so what is null? If linked list does not exist, right? Not exist, right? Second thing is, if max length occurred. I say you just insert something. I say insert in the linked list. So what if there is a restriction that our linked list should have a length of 100 and interviewer is asking you to insert 101, but that comes to a base condition. You should ask, what is the number of cases? Should I take care of these conditions as well? These conditions as well, right? In these cases, so when you ask this kind of questions to the interviewer, he gets impressed and he actually thinks what you're trying to write, and he helps you in the process, right? He helps you in the process. So at this point, what am I trying to do is, there is a method, there is a linked list insert, what do you call it, class that I've already written. So let me try to write this. Module. I told you one more thing that we are going to do as part of today's session is the modularization, right? So I'm saying that we'll be dealing with the modularization as well. So straight away, let me code line by line in front of you so that it becomes easier for you to understand, right? So here it is. I'm taking a class called LinkedList insert. Sorry, taking a class called LinkedList insert. Right, taking a class called LinkedList insert. So LinkedList insert, it should obviously be containing 3 methods, right? So what are those 3 methods? Insert first, insert last, and insert at index, right? So let me start with insert first. So let me try to write down the base cases. What are the cases that we are trying to achieve over here? What are the cases that we are trying to achieve over here? Are insert first, last, and at an index. At an index, right? So straight away, let me try to write these 3 methods. This is called as modularization, guys. So public node insert first, right? Eclipse is giving me a big problem today. I don't know what's happening to this. Okay, so I'm writing a method called insert first. So what are the parameters that I've taken in insert first? In insert first, I've taken 3. I'll be returning a node, obviously, because I should be giving the head pointer, right? But in insert first, I should be even pointing a parameter which is of type node, and I should be giving the head, right? I should be giving the head. So as I told you, insert first is something that we have written the method signature. So this is called as method signature. And yeah, just by looking at the method name, we are able to see, yeah, we are trying to do something, do some insertion into our linked list, and we are trying to return the pointer to the start of the linked list, right? So let me try to give you the base condition. So before that, obviously, as per our discussion, we should be returning a particular node which is having some data. Let's say I'm taking that as int x. Okay, I've taken that as int x. So here, since I would always be returning that, so what am I doing? I'm creating a reference variable called q and saying, so here I'm passing node, and what is the parameter, what is the input for that? I'm initializing that with x, right? I'm initializing that with x. So here, what we have to write the base condition, as I told you, base condition. Okay, so what is the base condition saying? The base condition is saying if head is equal to null. So what happens when your head is equal to null? So you'll be returning what? You'll be returning q, right? So you'll be returning q. Let me try to write it down for you. So what is our first case saying? So let's say our first base case is saying that we do not have anything in the linked list. So what you will do, you will create a node called Q. You will be creating a node called Q. So what is that Q saying? So this is Q, right? So X is the data that we are passing. We have created a node called Q. Okay. So this is pointing to the next, right? So this is what we have done. Let's say there is no linked list at all. So what you do, you should be inserting at the start of the linked list, head of the linked list. So without any second choice, you'll be returning the same Q so that that becomes a head now. The same thing you have done over here, right? So your base case is gone. Now, what you should be doing, you need not iterate over here. You need not iterate, but what you have to do, you just need to insert at the start and return it, right? So as I told you again, in this particular program, it doesn't make any difference, but I'm following the standard of our class node called P. I'm initializing that to head, right? After I initialize that to head, what am I doing? I say Q dot next equal to P, right? And what am I doing? I'm returning Q, right? I'm returning Q. So what am I doing as part of these three codes, right? So let's say now we already have a linked list, something like this, right? We have a linked list, something like this. It is, okay, let's not have alphanumeric data types. Let's say it is having something like this, 1, 2, 3, right? So it is already having something like this. So this is null, right? And this is head. But here you're saying Q should become the head, right? Q should become the head because we need to insert something at the first. So there is a null pointer here. It is actually initially pointing to null. So instead, what am I doing? I'm removing this pointer and I'm saying Q should point to what? Q should point to the already existing head, right? Already existing head. When Q points to already existing head, so we should be returning the head because we have already inserted something. So now this becomes our head. This becomes our head. So that's fine. Our program, we are returning Q. We are not returning head. We are returning Q. So when you're returning Q, which means the person who is calling this method obviously be thinking, okay, this guy has sent me the head again so that I can again iterate kind of. So this is how you insert something at the first of the linked list, right? First of the linked list. Now, let me try to come back to the second part, which is insertion at the last, right? Public insert last, right? When I say insert last, again, I'm doing the same thing. I'm taking over here, right? I'm taking over here the same parameters and it should be returning me of type node, right? It should be returning me of type node. And again, the same base condition. What happens when there is no head, right? The base condition, I'm copying the same. Okay, base condition, I'm copying the same, right? Insert at last. Just a second, guys. So here, if we see, let's say now instead of you inserting this Q at the point at the starting point, let me try to draw it again or use the same diagram. So instead, this should not happen. Okay, this should not happen. Actually, what should happen is this is pointing to null, right? Instead of this pointing to null, this point should be pointing to the Q, right? The same thing. Let me try to draw Q here, right? So there is X and it is pointing to null. Okay, so instead of this pointing to null, now this pointer should be pointing to Q, right? This is our actual motto. This is our actual motto right now. So let me try to do the same thing as part of our code as well. So what am I doing? So here, if head is equal to null, then there's no point of inserting. I mean, we have already done this, but let's try to do the same thing also, right? I'm trying to create a node called Q and I'm returning that as well, So I'm returning that. There's no point of returning it now because you have inserted what you have not inserted anything. Again, it's the same case here. If there is nothing, then you are returning the queue that you have already created, right? Now let's move to the next part. What is the next part doing? Next part is doing that while, so I'm trying to write the loop over here, right? What am I trying to do in the loop? In loop, I'm calculating if. So what is this? Once again, so again, we have to take a pointer called p, guys. I told you, because before we try to modify anything, so I'm saying node p is equal to head, right? Node p is equal to head. I'm trying to do the same thing while p.next is not equal to null. Why do we write p.next not equal to null? I'll show that to you, right? Not equal to null. So while p.next is not equal to null, what you're trying to do, you're saying q p is equal to p.next, right? So at the end, what you're doing, p.next is equal to q. This is what you are doing. So, and then you are returning head. So why do you return head and all? I'll show that to you. Okay, why do you return head? I'll show that to you. So here, if we take this code as an example, we are passing this base condition, and after that we are saying p.next not equal to null. In the same example, p.next not equal to null. Let's say our p is somewhere like this. Our p is initially somewhere like this. Okay, so you're checking p.next is not equal to null. At the start of loop itself, you're saying p.next is not equal to null. Okay, then fine, come here. So again, you're checking p.next is not equal to null. So that is also fine. You come here. Now p.next is null here, right? P.next is null here. So that's why you're ending the loop over here. When you end the loop over here, what we are trying to do, when you try to end the loop over here, we are saying p.next is equal to q. So what is p.next? Our p is actually present here right now. So now this p is pointing, this next is pointing to the one that is already created, which is q, right? So what we are trying to do again, we should not return anything. We should be returning the head. The reason is we are not inserting at the start, but we have inserted something at the end, right? This is what insertion at the last goes to, right? This is what the insertion at the last goes to, right? So at this point, guys, I just want to ask, see the collaboration with you. Uh, uh, Please message me if you are able to understand what we have done till now. You can message me here. Okay. Other people, I'm waiting for you. Okay. The last one I need to repeat. Yes, I'll do that. Oh, line node next. Okay. So I'll tell that to you. See, in our representation of the class itself, this is why, I mean, this comes with this comes with practice. Okay. In our representation of the node itself, what we have done, we have taken a variable called next. Okay, that is of type node, right? When I say node not dot next, node dot next, so you should be returning of type node, right? It's all basic data types in Java. If you actually go and see the first lecture of data structures, the first lecture, I told you we'll be learning some concept on memory organization, memory things, what happens when you create a diagram, when you create an object, what actually happens internally. So I told you that there are various steps which will be going on internally. So I told you, if you learn this properly, you will appreciate that concept when you start learning linked list, right? Again, I tried the same, guys. Maybe see the first 15-20 minutes of the first lecture that we have taken. So that should be of memory organization. What happens when you create an object? Here in our case, we have created an object called node, and here we have a reference variable called next of type node. So that is why whenever we say in our program, whenever we try to say p.next, what is p.next? What is p? Actually, p is of type node. And I say p.next, dot next, when I'm trying to do, next is of type node, right? So again, it's trying to point to the next node, right? Again, it's trying to point to the next node. So this is the thing, guys. Like this only comes when I mean you are along with the class, no problem. Okay, so repeating the same program once more, right? Repeating the same program once more. So what is that? Linked list insert from line number 15 to line number 27. What have I written? Have written something like this, which says insert last, right? Our requirement here is to insert something at last. Let me draw it to you so that that becomes easier. The reason why I'm telling this again is, guys, because next program will be very tough. Next method will be very tough when you don't understand this. So this is what it is. I've written, so let's say now I'm taking something like this, right? It has 1, now this has 2, this has 3, right? This is head, and this is coming as null, right? This is how it is. Now what is our requirement saying? Our requirement is saying insert something at the end of the linked list, at the tail of the linked list, right? So let's say I'm taking, so input for me is, let's say input for me is x, right? Input for me is x, something like this. So this is pointing to null now, because as part of my line number 16, what am I doing? I'm saying q is equal to new node of x. So this is called as a q, right? This is q. So this queue has been created, a new node has been created with the data called x. X is something that we are passing here, right? We are passing here as an input. So we are passing it, and after that we are pointing that to null, because this already happens. This also we covered in our previous class. Why is this pointing to null, etc., etc. So here, what is our requirement? Our requirement says we need to insert this at the end, right? What is the end at present? End at present is this. So in our modified program, after we try to implement the method, the end should be this one, right? The end should be this one. So what is the actual thing that we need to do? We need to do only one thing. If you observe, we need to remove this link. And we need to point this to the start, right? We need to point this to the start. And obviously, since you are removing this one, so when you try to put the link over here, the link is directly coming here, and finally it is pointing to the newly implemented node, and we are returning, and this is again pointing to null. So since this is again already pointing to null, we need not take care of any other things, right? The only thing that we are trying to do here is we are modifying the link. We are taking this address and maybe trying to point this to the next node that we have already created. So to achieve this, what we did, we have initially created a node called q on what? On line number 16. And from then, here is the base condition that you can understand. And then here in the while loop, what we tried to do is to achieve this functionality. In the while loop, what we did is we have taken a variable called p. And this p we are trying to point to the head, right? As part of our while loop, what did we check? We checked one thing, while p.next is not equal to null. So what is p.next here? P.next is actually 2, right? P.next is actually 2. So p.next is not equal to null. So our condition is passing. Now the p is coming here. Now p is not this, p is this right now, right? So again the same thing. What we did not do anything. Again we came to the loop. Again what we did, while p dot next is not equal to null. Now here is p. Now again p dot next, p is again going and checking here. So p dot next is not equal to null. So what we do, we again move forward. This moving forward is present in what? In line number 23. It's present in line number 23. So it's present in line number 23. Now what is p? P is this. Now again we are checking p is not equal to null or what as part of line number 22. Now what? P dot next is actually null. It's actually null. So what we do, we break the loop, we come out of the loop, and we come to line number 25. Line number 25. At this particular point only, we are saying p dot next is equal to q and nothing else. P dot next is equal to q and nothing else. And so we are able to insert that at the last, and we are able to understand in this particular way. So you understood now, Tanmay? Okay, awesome, great. Right, this is very important for you guys to understand all this, guys. The reason is, when you don't understand this, the next method that I'm trying to write will become very hard for you. Right, this is how, like, let's say the next method takes a little bit more information, but the same thing, you try to take examples. Any code that you don't understand, you try to take examples. This actually is called as dry running. Right, this actually is called as dry running. When you try to dry run your code internally in your memory or diagrammatically, or you try to write that down on a piece of paper, so it becomes easier for you. Now our final agenda for today is to find out that insert insert at a particular index, right? Inserting at a particular index. So I'm trying to write a method something like this, right? Public, even though I don't write static, I'm not going to run it over here, that's fine. So public node. So I'm trying to write something like this. So I told you method signature is very important. Just by looking at the method itself, someone who's reviewing your code would be able to understand that you're trying to insert something at a particular index. So I'm having the same two parameters. I'm copying those, pasting them over here. Okay. So I'm trying to return something which is called as a node, So here, let me try to explain some cases for you. Okay, let me try to explain some cases for you. There are some cases that you need to take care of. So what is that? Let's say I told you finding the length of the linked list is important for us, right? Finding the length of the linked list is important for us. So I'm I'm coming to one case where if the length of the linked list is zero, right? This is one case. Thinking extreme, guys. If the length of the linked list is equal to zero, so when it is equal to zero, an interviewer is saying, I mean, giving you a position called 9. So insert me a node called X at position 9. But as part of your base case handling, what you came to know, the length of the linked list is zero. When length of the linked list is zero, then there's no point of going ahead and insert is something at 9. This comes to exception cases, guys. Exceptions, yes, you will be, I mean, you will be seeing those as part of your Java course, or if you already know them, that's fine, no problem. So this comes to exception cases where you are trying to give an index which is more than the length of the linked list that is already present, right? So for this, what I'm trying to do is, we already have written a method. So what is the method that we have already written? The method is linked list length, right? Get length. So I'm saying, let's say I make it static. Okay, so I make it static and I'm calling it straight away like this. Let me save this first. I'm saving this first. Yeah. So here, as part of my first step, I'm doing something like this. Dot. I should make this one also static so that I can straight away call them. So the first step that I'm trying to do is trying to find out the length of the linked list. So by finding out what do I get, if they are passing the index, so they should even be passing one more thing, guys, which is called as index, right? So when you try to do something like this, they'll be passing something called as int. So they'll be passing something called as an index, right? So here what you did, you said get length. So I'm doing one thing, int length is equal to, I have taken a variable called length, and I'm trying to find out what is the length of the linked list that I am passing, and I'm storing that in a variable called length. So variable called length. Okay. So what am I trying to do again here? This will be handy. This will be handy. This is called as thinking ahead of the code. So obviously you will be modifying something and you'll be returning, right? So that's fine. I'll try to write that. Now here I'm implementing the condition straight away. If what am I trying to do? If index is greater than, what is that? If index is greater than length, right? Let's say our length of the linked list is 3 and you're trying to pass an index which is 10. So which means it is a base condition. Here what you can do, I'm not writing the actual code here, but here you can print that this is a condition which is abnormal, which is not expected, right? This is a case where you can think that the case where it is not as expected. So here, or you can do one more thing, you can throw an exception. So that is with the contract that you are discussing with your interviewer, etc., etc. So this is one condition that we are handling, right? This is one condition that we are handling. Now again what happens is, let's say again this condition we handle, there will be one more condition, right? One more condition where they are saying the index is 0, right? When somebody is passing the index is 0, which means indirectly they are saying insert at start, right? Insert at beginning. When index is 0, insert first. Indirectly interviewer is saying you need to insert first. But this is called as code modularization. You have already written something like this. Called insert first. So what am I trying to do here? I'm trying to use that method here. If index is equal to 0, so what am I trying to do here? I'm trying to do nothing. I'm trying to insert first. So indirectly I'm calling this method, right? Let's say I'm making this also static here. Okay. The reason why I'm making this static is so that it decreases the number of code, lines of code, guys. We need not create an object and try to call on top of that object. So here, when index is 0, what am I trying to do? I'm trying to I'm trying to call this insert first, right? Insert first. Insert first, right? We have written something like this: insert first. We already have the head and we have the index. Index is what? Index is 0. No, this is an X. I'm saying the data is 10, right? We need to insert a node with the type of 10 at first, right? So so what we are doing, what is this insert first doing? Insert first will insert something and it is trying to return you something of type node, right? So straight away, if this condition comes, then I'm saying return insert first. All right, I'm trying to return whatever this method is calling for me right now. So we have taken care of one more condition. This is one more base condition for your method, and you have achieved that by code modularization. The same code that you already wrote, you're trying to reuse that. So let's come to the next condition. So what is this next condition? If index is equal to length, right? If index, so what you're trying to do here, if index is equal to length, so same thing. So what we did, so let's say index, I'm saying 3. This is 0th index, this is first, this is second. Okay, in the second index you're trying to insert something, so which means the length of the linked list is here is 3. But here one more thing that you want to want to see is the index and the length of the linked list. Length of the linked list in this case is 3. Let's say the index, let's say we are thinking that this is starting with 1, 2 and 3, which means the index is equal to the length of the linked list. Indirectly what we are saying that you try to insert something at the end, right? You try to insert something at the end. The same thing again I'm doing. So what am I doing? Insert last. Okay, insert last. Okay, since this is not static, I'm not able to see that in the suggestion. Okay, so how am I doing that? In the Eclipse there is this control plus space, so that gives me the method suggestions. I'm straight away calling insert last. Okay, I'm straight away calling insert last. So this is the insert last. The same thing, it's again taking head, and then it's taking something called X. So here I'm saying, instead of, so I'm again passing, let's say 20. We need to insert at last, it is 20. So what is our if condition? If index is equal to length, right? So this is second case, guys. So we have handled two cases with the methods that we have already written. So now we are left out with one last case where it is not at the start, not at the end, but it is somewhere in the middle, right? It is somewhere in the middle. So let's try to write code for that as well. It's somewhere in the middle, and let's try to write code for that as well. So we are done with the base conditions till now. So first thing is, index is greater than length, then index is equal to 0. We are trying to insert something at first. When index is equal to length, then we are trying to insert something at head, insert something at head, right? So here, what am I doing here? If you see in our example, let me try to use a different color so that it becomes easier, right? In our example, let's say I try to insert something at a position called at some position, right? This is my new node that I need to insert, and it is X, or let's say it is Y, right? So what happens, let's say I need to insert it somewhere over here, 1, 2, at the index of 2, right? At the index of 2, I got this as an input. So here the only thing that I need to do is I need to remove this link. This link should be removed, and what should happen, this should be pointing to this, right? And the next pointer should be pointing to something like this, right? So this link should be removed, and this next should be pointing to the address of Y, which you have created newly, and this next should be pointing to already present in this middle. So how do we achieve that? We can achieve that using our programmatic approach. So the following is the programmatic approach that I'm trying to do. If you observe here, we need to have something called as a temporary variable, right? As we code, we can able to understand. So what I did here, we will be dealing something with the iteration. So the first thing that we need to do is we need to do something like this. Have base condition node p is equal to head. Okay, so I've written something like this. Node p is equal to head. Guys, it takes just a little bit more time. We'll be completing it soon, right? A little bit more time, we'll be completing it soon. So node p is equal to head. So again, trying to do something like node q is equal to so here I'm trying to create a new node with the data called X. So I told you with the data called X, all right? So I've created that. So after that, what I did, let's say I'm doing something like this. If p is not, I'm doing something like this. While p dot next is not equal to this, similar kind of a coding, guys. Similar kind of a coding. Do not confuse at all. While p dot next not equal to null. When you are saying p dot next is not equal to null, so what you are actually doing here at this particular point, guys, at this particular point, so what happens in the same diagram, for example, let's say I have to do two different things. First thing is So I need to create a new node, something like this. I have already created. The second thing that I need to do is I should have, so when this node, this link is gone, right? This link is gone. I told you this link should be gone. So when you make that this link is gone, there should be some variable which is holding the value of this node. The reason for to hold the value of this node is if we do not hold the value, then it will be lost somewhere in the memory. So that is why we may not form this link, right? We may not form this link. So that is why what am I doing is this at this particular point is I'm taking a node called R, node called R. So node called R, and what am I doing? I'm saying node called R is equal to p dot next. So as I told you, we are holding this value. We are holding this value in the node called R. So what is this called as? This is called as R. This is called as R at present. So in our case, right, node R is equal to p dot next, right? So we have done this. Now what happens? I told you that we are passing some index, right? We are passing some index. So what is the way for us to calculate that we have come to this particular point? What I can do is I can take a variable called count. So let's say the index is 2 in our case. Let's say I can have a variable called count, and I can say that I can increment the count as we move forward. As we move forward, I can increment the count, and at the particular point where we reach that, when we reach that, we can break the loop, something like this. Something like this. So what am I doing? I'm trying to take int count equal to 1. Okay. So you have a variable called count, and you are incrementing that to 1. So as part of our condition, I'm trying to check something like this. If so, what is the condition that I'm checking? If index is equal to count, which means you came to a point where you need to insert, right? You came to a point where you need to insert. So this is our condition now. Index is equal to count. When insert is equal to count, then what you're doing the same drama over here, what you did, right? The same thing. Is it? Yeah, okay. So when this condition has occurred, what is this condition? This condition has already occurred. So what you're trying to do, you're playing the same drama. What you're doing, you're making R that is already present here. The 3 is R. This becomes P, and we need to insert this as a Q. So here what happens, I'm doing something like this. P dot next is equal to Q, right? And then Q dot next is equal to R. So what is the other? Q dot next equal to R, right? So after that, what am I doing? I'm trying to break this condition. So I'll be breaking this condition. So after I break this condition, the only thing that I need to do is after, if you see here, guys, if you see here, even if the control doesn't come into this if condition, we need to do these two important things here. So we should make sure that P is incrementing every time when you are there in the while loop, right? So I'm doing P is equal to P dot next. And what am I doing? I'm incrementing count. And this is the code that we have written. So what am I doing? I'm incrementing the count. So with this logic, I'll be even inserting at the particular index that I want to, or I intend to. And at the end, what am I doing? I'm returning the head. This is very important thing, guys. This is very, very important thing. So I'll be returning head. So I'll be returning the head. This is a simple code. I mean, even though it looks complex, just by taking the examples, just by visualizing what is happening internally, just to achieve this, what is the thing that I can do? What is the thing that I cannot do? If you have questions of this kind in your mind, then you can write this code. Even though this looks so big, the code looks so big, you have written line by line, one by one, just by thinking, okay, at this particular point, this may happen. So with this, guys, so even this code will let you know that you are inserting something at the middle, right? Inserting something at the index, right? Inserting something at the index. There'll be different hacker rank problems: the insert at first, insert at last, insert at a particular index, whatever. So what we have written, what we have written is, we have written a separate method for inserting at first, we have written a separate method for inserting at last, we have written separate method for inserting at a particular index, right? With this, whatever is the case that we are saying, and we have even taken care of cases where the interviewer has given you a different input, he tries to confuse you, etc., etc. You started asking him questions, you tried to find out what is the actual requirement, and finally you have coded, and finally this code will cater all the things, guys. Everything you give, whatever the input that you give, so this will cater all the needs, right? Straight away I'll try to do one thing. What is that? Okay, I'll try to do one thing. What is that? Let me try to run this, and explain, show that to you in HackerRank. Or I can do one thing, guys. Just give me a second. I'll open up our material. So I'll be sharing the notes for today. And I will be explaining you that these are the things that we have taken today. And the thing that you need to do is, I know just by looking at the first glance, this becomes a little bit hard for us to understand, but that's fine. With practice, you'll be able to write this code just like that, guys. Less than 2 minutes, less than 1 minute, I challenge. But the practice is very important for you. So after you practice, you'll be in a position to actually answer that even in a better way. So I'll be sending you the notes for today, and you should be in a better position to actually run this program. This is a little bit bigger program. Till now we have, okay, please write on the last one. That's what I'm trying to do, Tanmay. Okay, fine. Let's write on the last one. That's what he says. I'll try to open up the one that I already written. LinkedList insert, right? Is it fine? It's not having any problems. Is it having any problems? Okay. Okay. You can have something like this, Tanmay, but see, I think it's taking more time than what we intend. Maybe dry running, I'll put it to tomorrow. Yeah, it's going to, that's fine. We are going to end this class today. So I'll try to write on this code for you tomorrow. So what I want you guys to understand is, take this. I'll be giving you the same code in our class notes as well. So the only thing that I want from you guys is, take this code, try to run it on a piece of paper, try to write it on a piece of paper. And after you've done that, so you should be in a position to answer this HackerRank question, right? I'll be giving you the HackerRank questions link as well. So with that HackerRank questions link, it should already be having the code. The only modifications that I did in the code is, HackerRank is following this naming convention. Instead of having a node, what they are trying to do is, they are doing something like single linked list node or whatever. So they're trying to do that. So you just need to replace the node with single linked list node, and this code should be working for you. Properly, right? At this particular point, let me see that. Okay. Okay, so I'll be showing all those things to you. Guys, we are consuming more time for today, I guess. Let's resume tomorrow's class by dry running this code. But homework for you is to actually understand the code that we have already written in this class, step by step, line by line. We have written the code, and try to visualize what is happening internally. Take a piece of paper, try to write it down on a piece of paper, and try to find out that you're doing that in a proper way. So with this point, guys, I just want to ask you, are you able to follow this class? Let me put a poll. Okay, are you able to follow today's class? Good. I'm sure, guys, maybe initially if you try to write this codes or practice this codes, etc., so what happens is in internet, even the same question, if you see the editorials or the discussions of HackerRank, what happens is there are so many discussions which go on. They write complex codes, they try to use different concepts, or the same code they might have written in less than 10 lines or whatever. So it's not the number of lines of code, guys, the modularization that you follow, and at the same time how well you are able to understand the thing that you are already writing. So that's important. When you try to solve the same problem in HackerRank, they give you different kind of a questions, different kind of a solutions. But don't get lost for yourself in those discussions, guys, because I've been trying to make you follow a particular standard, so that even if it is a complex problem, even if it is simple problem, you will be following this trend, so that complex problems will become a little bit easier for you. If you try to write simple code for for simple problems, then finally actually you're not learning how to deal with complex problems, guys. So try to follow these conventions, these conditions. These conditions will be applicable to any code that you write. Any question that the person asks you, you'll be done with your 50-60% of coding just by following these standards, guys. Right? You're following me in this? You agree with me? Okay. Uh, Guys, I'm asking us simple poll. Please try to check whatever answers that you feel are relevant, so that I can understand what actually it is. I'm expecting answers from everyone. Only 3 people have answered till now. Whatever comes in your mind, just try to answer, guys. Whatever comes in your mind. 2 more people need to answer. 5 have answered till now. I'm waiting for 2 more people's answer. Okay, let me end the poll and I'll show the results to you. Okay, you should be able to see the results. Most of the people say that need to check once more, which means this is a subject where you have to give time after learning it, right? Give little bit of time. This is just evident, guys. This is the answer that I expected also. For the person who said yes, awesome, that's great, really. But even for you, what I say is you need to practice, and if you don't practice, then it's like that. Same thing, need to check once more. Not just this program, guys. You try to learn any subject, be it Java, be it data structures, be it any subject. You need to follow the instructor, so that what happens is, like, you will not be having any backlog, and you'll not be left out somewhere in the crowd. So don't give so much of time, just give little bit of time. Maybe half an hour or 1 hour a day, and try to understand, try to write it on a piece of paper, try to see if this is working or not. And finally, this becomes easier for you. The tough subjects like data structures, people think this become very easy, guys. Believe me, this becomes very easy when you try to understand the small programs that we are trying to trying to learn at the start of the class, right? With this point, guys, it was a very nice session with you all. Happy day. We have taken more time, but tomorrow I'll start at time, and we will learn a little bit more tomorrow, right? Thank you, guys. Thanks a lot.